Hey guys, the objective of this video is to do an abrupt change in stress. We're now looking at one-way drainage and we're still going to make beta equals a half. So in terms of the flow chart, we're at an abrupt change in stress, beta still equals a half, but we're now looking at one-way drainage. So we're on this branch here. So we have the exact same example, 8 meters of soil. The CV is the same, we've got the same value of change in the abrupt stress. So we're going to make beta equals a half. So we know beta equals CV times change in time on change on z squared. So to make this equal a half, we went 2 times 1 year over 2 squared, which gave us 1 half. So our layer subdivision is now divided into increments of 2 meters, and we're looking at increments of 1 year time. So we're going to come and draw up our table. So we have time, the stress, the change in stress. We're looking at z equals 0, z equals 2, z equals 4, z equals 6, and z equals 8. And because we're doing a one-way drainage case, because this is, say, an impermeable layer down here, this is an impermeable rock, and this is free to drain up here, we know that we have to introduce a dummy below this lowest level. So we need to introduce a dummy. So we saw that in one of the first videos we did, that for a one-way drainage case, we have to introduce a dummy underneath the lowest layer, which simulates our z equals 8 as an impermeable layer. So we're going to come and rule this off. So let's look at time equals 0, 1, 2, 3, 4, and 5 years. Okay, so here are our columns. Now, we will now come and fill in the stress at any point. So the stress at any time, it's all 100 kPa. There's no change in stress anywhere. So the stress everywhere is 100 kPa. The change in stress, so at year 0, we had a sudden increase from 0 stress to 100. So there's been a change of 100 kPa. But everywhere else, there's no change in stress from year to year. Now we can come and fill in our boundary conditions. So we know that because we have a permeable layer at the top, the water is free to drain. So that means we have no excess pore water pressure at any point. We also know that at our first situation, we had a increase of stress of 100 kPa, which is felt throughout the layer. So this 100 is felt everywhere. And we know that because this is 100 at our z equals 6, that's going to make our dummy also equal 100. So we can go ahead and use the formula to increment this forward, to march the solution forward. So we know that for beta equals a half, so when beta equals a half, our formula for UB of time 2 is equal to 1 half outside of UA of time 1 plus UC of time 1 in brackets plus the change in stress for that year. So if we were to find this value here, it would be that value, so 100 plus 100 divided by 2 plus 0, so that's going to give us 100. Same thing here, this value here, so if we were looking at this value here, it would be that one and that one, so the one above and below in the previous year, so will equal 1 half of 100 plus 100 plus 0 change in stress. So that'll give us a value of 100. So we can fill this in as 100. Similarly, that would be 100. This one would also be 100. And we could find that this we fill in as 100 because we always take the 1, 2 above it for our dummy. Now we can march it further again. So this value here would be 0 plus 100 divided by 2 plus 0, so that would be 50. This would be 100 plus 100 divided by 2 plus 0, so that would be 100. That would also be 100. That would also be 100. And similarly, we would bring this down to our dummy to get 100. Now this value would be 0 plus 100 here divided by 2 plus 0, so that would be 50. This value here would be 50 plus 100 divided by 2 plus 0, so that would be 75. This value here would be 100 plus 100 divided by 2 plus 0, which would be 100. This value would also be 100 plus 100 divided by 2 plus 0, so 100. And we would then, once again, get our dummy as 100 by just bringing it down. Now this value would be 0 plus 75 divided by 2 plus 0, so that would be 37.5. This value here would be 50 plus 100 divided by 2 plus 0, which would be 75. This value would be 75 plus 100 divided by 2 plus 0, which would be 87.5. This value would be 100, and we would bring down this value to our dummy, so that would be 87.5. This value over here would be 0 plus 75 divided by 2 plus 0, so that would be 37.5. This value would be 37.5 plus 87.5 divided by 2 plus 0, which would be 62.5. Filling in the rest, that would be 87.5. This would be 87.5, and we'd bring this down to get 87.5. So as you can see, our excess pore water pressures are reducing as we're going on in time. Eventually, as time equals infinity, our excess pore water pressures at any point will be 0. So guys, I hope that helps. Stay tuned for the next couple of videos where we're going to be looking at some other cases. And yeah, hope that helps.